It is Thursday, February 26th, 2026. It is the 57th day of the year, and right now, there is something developing in the atmosphere that I genuinely believe most people are sleeping on. And that is a problem, because the next major storm system to hit the eastern United States is not going to look anything like what we just went through. And that is exactly what makes it more dangerous than people think. Let me say that again. This storm is not going to come in as 2 feet of clean white powder stacking up against your front door. What is lining up over the next 5 to 7 days is a completely different animal, a storm that threatens multiple hazard types, simultaneously across a very wide swath of the country, from the Gulf Coast all the way up into southern New England. And historically, the storms that produce the most casualties and the most disruption are never the ones people are prepared for. They are always the ones that arrive quietly, looking nothing like the last big event, and then they absolutely wreck you. So let us talk about what the atmosphere is actually telling us right now. Right now, we are still digging out from what was arguably the most significant winter storm the Northeast urban corridor has seen in close to 2 decades. There is still snow measured in feet sitting on top of rooftops, clogging streets, and piled against every fire hydrant from Philadelphia all the way up through Boston. People are exhausted. People are storm fatigued. And that is precisely the moment when the atmosphere does not care about your feelings and sends in the next round. What the models are showing right now is the development of a complex, low-pressure system that is going to track very differently than the nor'easter we just watched bomb out to the southeast of Nantucket. That storm had a very specific signature. It was a classic coastal bomb cyclone, an explosive, deepening event where the surface pressure dropped more than 30 millibars in under 24 hours, pulling in a fire hose of cold air from Canada and a massive moisture plume from the Atlantic simultaneously. That combination is what gave us those 2 to 3 feet totals. The system we are now tracking is not going to do that, and that is what makes it so fundamentally different. What we are looking at here is more of a classic mid-latitude cyclone that originates over the central United States, draws its energy from a very different source, not the Atlantic, but a very sharp temperature contrast between an anomalously warm air mass sitting over the Gulf of Mexico and the brutally cold air that has been draped across the eastern half of the country since the blizzard exited. That temperature contrast is enormous right now. We are talking about a situation where you have 65-degree temperatures in Houston, Texas, and simultaneously, temperatures barely above 10 degrees in parts of upstate New York and northern New England. When you have a gradient like that, when you have that kind of thermal divide, you do not necessarily need a bomb cyclone to create serious problems. You just need the right storm track to exploit that boundary. So what is the storm track looking like right now? This is where the models are still in some disagreement, but let us walk through the 2 most likely scenarios based on what the European Center for Medium-Range Weather Forecasts model and the Global Forecast System are showing, because both of them agree on the general shape of this event, even if they disagree on the finer details. Scenario 1, which I would currently weight as the slightly higher probability outcome, shows the low-pressure center developing somewhere over the Central Plains, probably over Oklahoma or Kansas, around late Saturday night into Sunday morning. It then tracks northeast, crossing the Ohio Valley by Sunday afternoon and evening, and eventually lifting out into southern Canada by Monday morning. In this scenario, the storm is fast-moving. Oh, that is one of its defining characteristics. This is not a system that is going to sit and spin over the same area for 36 hours like a snow globe. It moves quickly. And when storms move quickly, the precipitation types can change dramatically over a very short period of time. Here is what that matters. In Scenario 1, the warm sector of the storm, the air ahead of the cold front surges northward across the lower Mississippi Valley, Tennessee, and into the Ohio Valley. That air is genuinely summer-like in terms of its moisture content. We could be looking at dew point temperatures in the upper 50s and even low 60s across portions of Mississippi, Alabama, Tennessee, and Kentucky ahead of this cold front. That is the kind of dew point you associate with late spring severe weather setups, not late February. And so in Scenario 1, the severe weather threat is real, and it is significant. We are likely looking at a moderate risk level, or in certain specific corridors, potentially enhanced, for damaging wind gusts, large hail, and yes, tornadoes, across portions of the Mid-South and Ohio Valley. The Storm Prediction Center has not issued its formal outlooks for this event yet as of when I am putting this together, but based on the ingredients I am seeing, you should absolutely not be surprised when those outlooks come out looking serious for this region. Now here is where Scenario 1 also creates a complicated picture as you move farther north and east. Because behind that warm sector, you have got this Arctic air sitting in place, air that has been locked into the Northeast and the Mid-Atlantic since the nor'easter. And what happens when a fast-moving low-pressure system pulls very warm, very moist air northward and slams it into a deeply entrenched cold air mass? You do not automatically get snow. You can get something far more problematic. You get an ice storm. The ice storm scenario is what I want to spend some time on because I think it is genuinely underappreciated right now. Across a zone from roughly the Ohio River Valley up through West Virginia, western Maryland, and into portions of central Pennsylvania, the setup for a significant ice accretion event is present in both of the primary model solutions. We are talking about a scenario where warm air rides up and over a trapped cold air dome. Precipitation falls as rain aloft, and then freezes when it hits the sub-freezing surface temperatures below. A quarter-inch of ice accretion causes problems. A half-inch of ice accretion causes major power outages. And in some of these scenarios, we are looking at the potential for 3/4 of an inch to an inch of ice in the worst positioned locations within that transition zone. If you are in any of the aforementioned areas, and I am specifically thinking about cities like Charleston in West Virginia, Morgantown, Cumberland in Maryland, Johnstown in Pennsylvania, you need to be thinking about an ice storm as your primary threat, not snow. Now, where does Scenario 2 differ and why does it matter? In Scenario 2, which the European Center has been hinting at in some of its ensemble members, the low-pressure center tracks slightly farther south. Instead of developing over Kansas and Oklahoma, it develops closer to northern Texas and Arkansas. The track then takes it through Kentucky and Tennessee rather than the Ohio Valley, which pulls the warm air mass a little farther north before the system occludes. In this scenario, the severe weather corridor shifts southward toward Mississippi, Alabama, and Georgia, which reduces the tornado threat for the Ohio Valley somewhat. But it dramatically increases the ice and snow threat for areas from Virginia northward. In Scenario 2, you end up with a sharper, more defined snow band setting up somewhere between Washington and Philadelphia, areas that are already exhausted from what just happened. And in this scenario, that ice transition zone shifts northward too, putting places like Harrisburg and Allentown in a very difficult position in terms of precipitation type. The point is, whether it is Scenario 1 or Scenario 2, a very large portion of the eastern United States is going to be dealing with a meaningful weather impact between Sunday and Monday. The question is whether that impact comes in the form of severe thunderstorms, an ice storm, a snow event, coastal flooding, or some combination of multiple hazards at the same time. Let us also address the coastal situation, because this is where the nor'easter comparison breaks down completely. The last storm had an extraordinarily powerful onshore wind component that drove major coastal flooding along the New Jersey and Delaware coastlines, and that was while it was explosively deepening offshore. This next system does not have that mechanism available to it. It is a continental system. The wind field is going to be oriented very differently. For coastal New England, specifically eastern Massachusetts, Cape Cod, and Nantucket, the wind threat is much lower with this next system. That is good news for the coast. But, and this is important, coastal New England is still potentially going to be dealing with a significant snow event in Scenario 2, not from the primary system itself, but from a secondary low-pressure development that could occur along the coastal front after the primary system tracks north. We have seen this pattern before. The primary storm tracks inland, creates a temperature contrast along the coast, ice, and then a secondary low redevelops right along the coastline. If that secondary low develops, and both models are showing at least some chance of it, then Boston could be looking at yet another meaningful snow accumulation on top of what is already on the ground. Now let us get into specific precipitation totals, keeping in mind that with a storm this complex, the range of outcomes is wide, and you should weight these as scenarios rather than predictions. For the severe weather corridor, and I am thinking primarily about Mississippi, Alabama, western Georgia, Tennessee, and Kentucky. The primary threat window is Sunday afternoon through Sunday evening. The exact timing will depend on how quickly the cold front accelerates, but the most likely scenario puts the most significant storm activity between roughly 2 in the afternoon and 10 in the evening, local time across that corridor. For the ice storm corridor, West Virginia, western Maryland, central Pennsylvania. The threat window is longer, potentially lasting from late Sunday morning all the way through Monday morning, as the warm air overrunning the cold dome sustains freezing rain conditions for an extended period. For the snow corridor, and this is going to be more northern and inland than the nor'easter, we could be looking at accumulations ranging from 3 to 6 inches in a low-end outcome across portions of upstate New York, Vermont, and New Hampshire. In a higher-end outcome, especially in Scenario 2, 6 to 12 inches becomes possible for the same areas. Interior New England, away from the coast, may actually see the heaviest snow totals in a higher-end scenario. For the mid-Atlantic, Philadelphia, Baltimore, Washington, the precipitation type question is the dominant uncertainty. In a warmer scenario, Nice, this region sees a messy mix of rain and sleet, with perhaps a brief changeover to light snow at the tail end of the system. In a colder scenario, there is a possibility of a period of heavy snow, particularly in the northern suburbs of Philadelphia and in portions of New Jersey that are still under a deep, cold air mass from the previous storm. What I want to emphasize here is the difference in character between this storm and the one we just experienced. The nor'easter was a clean, photogenic, everyone knows what is coming event. This next system is complicated. It is messy. It is the kind of event where a 60-mile difference in storm track fundamentally changes what your town experiences. It is the kind of storm where one side of a ridge sees 12 inches of snow and the other side sees nothing but rain. And it is the kind of event where the people who underestimate it, because it does not look as dramatic on social media, are the ones who end up in the most trouble. There is also an element of cumulative impact here that I think deserves serious attention. The infrastructure in the Northeast right now is already stressed. Power crews are still working on restoring outages from the blizzard. Snow removal operations have barely made a dent. Emergency services are still stretched thin. And we are talking about bringing another significant winter weather event into that environment within 5 days of the first one clearing. That changes the calculus for how impactful this storm ultimately is. If you are in any of the ice storm corridor areas, your preparation should be happening now. Ice storms are uniquely dangerous, not just for power outages, but for travel. A thin glaze of ice on the roads at 3 in the morning when the freezing rain is heaviest is something that catches drivers completely off guard, especially when they are thinking of this as the follow-up storm to a big nor'easter and not as a standalone serious weather event. The atmospheric pattern going forward through early March is showing continued active weather across the eastern half of the country. The jet stream remains highly amplified with a persistent ridge over the western United States, forcing deep troughs into the central and eastern portions of the country. That pattern is a snowstorm factory for the Northeast and a severe weather pattern for the South simultaneously. We are not transitioning into a quiet, settled period anytime soon. What we are seeing right now is consistent with a pattern that historically produces multiple significant storm systems over a 3 to 4 week window. The scenario analysis continues to evolve. The models will likely come into better agreement over the next 24 to 36 hours as the energy that will fuel this system becomes better defined in the upper atmosphere. What I can tell you right now is that regardless of which scenario ultimately verifies, this storm is going to demand attention from a very wide area of the country, and it is going to demand it in a way that looks nothing like the last one. And do not let the familiarity of another storm warning lull you into complacency. The most dangerous assumption you can make right now is that because you survived the blizzard, you know what this one is going to bring. You do not. And that is exactly the point. What is setting up here is one of the more complex multi-day weather patterns we have seen in years. Layers of cold air, warm air, and moisture all competing for the same real estate across the eastern half of the country at the same time. This is not a one-storm situation. It is a sequence, and each piece of it deserves serious attention. Stay weather-aware, stay informed, and make sure the people around you know what is coming before it arrives. If this breakdown helped you understand what is actually happening with this storm system, I hit that like button right now. It genuinely helps get this kind of detailed analysis in front of more people who need it. And if you are not subscribed yet, click that subscribe button and turn on the notification bell so you get these updates the moment they drop. We are going to be tracking this storm very closely over the next several days with daily updates as the picture sharpens. You do not want to miss a single one of those.